Good morning, this is Miss Triangle. This is lesson 3.3, proofs with parallel lines. So to start, put your date and topic in the upper right corner, whatever today's date is, and the section is 3.3, proofs with parallel lines. All right, then you're going to set up your lines, you're going to write your essential question. How can you write proofs? Yay, proofs are back for parallel lines cut by a transversal. We're on learning target 3D. I can use the parallel line theorems and their converses, and we'll remind you about what the converse is, to determine if two lines are parallel and to write two column or paragraph proofs. So which converse, my question here is, which converse statements are true for parallel lines? So just converse is when you change the order, right? If P then Q, then Q, then P. So what is a converse here? Basically, it's used to prove the converses. The way you can kind of keep it straight is they're used to prove if two lines are parallel. Okay, so for example, if you get the corresponding angles converse, right here, the corresponding angles, if you got that angle 2 was, let's just say 50 degrees, and the corresponding angle 6 was also 50 degrees, if those are congruent, then you could conclude that J is parallel to K. So we talked about corresponding angles before, but we went the other direction. You knew that line J and K were parallel, so therefore corresponding angles were congruent. So this is just going the other direction. You're getting the angles, and then you're proving that the two lines are parallel. All right, so again, you do not need to write down every single thing for these. I would probably write the name and draw the picture if it was me. That's what I would do. So this is just reminding you of where alternate interior angles are. So if you get that angle 5 and angle 4 are congruent, like we'll just throw in, I don't know, 130, 130, then you can conclude that yes, J and K are parallel. Okay. Theorem 3.7, that's the alternate angles. So again, I would write the name alternate. You can abbreviate alternate and exterior angles. So if you're getting that angle 1 is, let's just say 150, and that angle 8 is 150, you can conclude that line J and K are parallel. Okay. Consecutive interior, if you're getting that those two angles are supplementary, not congruent, but supplementary. So for example, 80 for angle 3 and 100 for angle 5, something like that. Then you can conclude the lines are parallel. Okay, the only one that's kind of new or different here is the transitive property. So for this one, you may want to write this one down. I would write this one down. Basically, it's saying if you know that if P is parallel to Q and Q is parallel to R, then P and R are also parallel. Whoops. Okay, let me zoom out what is happening here so you can see this whole page. Sorry for the crazy lines. I'm just going to go ahead and erase this. But transitive property, I would pause the video and make sure you have that down, because that one is a little bit different and harder for people. All right, let's keep going. So here's example problem 1. So find the value of x that makes line M parallel to line N. So I'm getting this angle, 3x plus 5 and 65. I want to ask myself, what type of angles are these? What type of angles? Top right, these are corresponding angles, so they are congruent. So they are both 65 degrees. So I need to set 3x plus 5 equal to 65 and solve. So I subtract 5, 3x equals 60, I divide by 3, and x is 20. So if x is 20, that would make line M and line N parallel because the corresponding angles would be congruent. All right, example 2. Prove that if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. So given, let's write the given and the prove, and let's draw the diagram. Then I'm going to go ahead and use a 2-column proof. And I'm going to abbreviate, so I'm just going to put statements and reasons as S and R. I always start with what's given. So what's given is that angle 4 and angle 5 are congruent. Okay, I'm trying to prove that G is parallel to H. All right, let's look at the diagram. Let's look at what we know. So I'd probably start right here. I know that angle 1 and angle 4 are vertical angles, and so those are going to be congruent. So angle 1 is congruent to angle 4. They're vertical angles. I also know that angle 1 is congruent to angle 5. What kind of angles are angle 1 and angle 5? What would my reason be? Those are corresponding angles, or I could also use the transitive property. So either one I would accept. I'm going to put transitive property just because if you look up here, I said that 4 and 5, that was given. Then 1 is congruent to 4. So if 4 is congruent to 5 and 1 is congruent to 4, then I can say 1 is congruent to 5 using the transitive property. Lastly, I can end saying line G is parallel to H. And if you look right here, we said that angle 1 was congruent to angle 5. Those are what kind of angles? 1 and 5, those are corresponding. So what would my reason be? That's going to be the corresponding angles converse. And you do need to put converse. That is important. How do you know if you put converse or not? Converse is used to prove that two lines are parallel, which I did right here. Line G is parallel to line H. So pause the video, rewatch if you need to. We'll try some more. All right, in the diagram, R is parallel to S. So you do need to write the question. R is parallel to S. Angle 1 is congruent to angle 3. Prove that P is parallel to Q. So we do know that our vertical lines, R and S, are parallel because they're marked. So right here, R and S are parallel. We are trying to prove that our horizontal lines, P and Q, are also parallel. All right, so I'm going to go ahead and set up my table. Statements, reasons. I always start with what's given. So what was given here is that R is parallel to S. It was also given to me that angle 1 is congruent to angle 3. My reason is given. Those are both given to you right here in the problem. All right, then let's think about what we know. So I do know that R and S are parallel. That's marked, so those are parallel. And so Q is kind of like a transversal through R and S. So that makes angle 1 and angle 2 congruent. All right, angle 1 is congruent to angle 2. Think for a second, see if you can get this. How do we know that angle 1 is congruent to angle 2? What kind of angles are those? Those are corresponding angles. I don't need the converse. I'm not saying two lines are parallel. Okay, for line 3, let me erase my picture a little because it's just getting so messy. All right, so we said 1 is congruent to 2. What else do we know? We also can use angle So let's think about what we know here. I'm going to see what have we written so far. So I've written that angle 1 is congruent to angle 3. Angle 1 is also congruent to angle 2. So then I can go ahead and say that angle 2, since it's congruent to angle 1, should also be congruent to angle 3. So what property did I just use? Hopefully you're starting to recognize it. That is the transitive property. Okay, then I'm going to highlight angle 2 and angle 3. Angle 2 is right here. Angle 3 is right here. What kind of angles? What kind of angles are those? If those are congruent, I can say the lines are parallel. I can say that P is parallel to line Q. And what kind of angles are 3 and 2? Those are the alternate interior angles. And is this going to be the converse? Are we saying two lines are parallel? Yes, we are. So I'm going to throw converse on there. Okay. So again, we would expect you to be able to, with some help, come up with this proof. We'd probably give you some of the lines and you'd be filling in some of the blanks. All right, here is our last proof. So you don't necessarily, you can draw the picture or you can write the words. You don't necessarily need both. I'll read it just as you're kind of writing it here. So the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So I'm going to go ahead and maybe sort of do a paragraph proof for this rather than a 2-column proof. So if basically I know what it's saying is I know that stripe 1, I'll call it S1, stripe 1 is parallel to stripe 2. Stripe 2 is parallel to stripe 3. Stripe 3 is parallel to stripe 4, on and on and on. Okay. So what do we know if everything is parallel to each other? Basically, we can use the transitive property using stripe 1 is parallel to stripe 13. Okay, so I think that was maybe a little bit easier to sort of write it out like this rather than do a formal 2-column proof. So sometimes, depending on the problem, the paragraph proof is kind of nice. Okay. All right, so hopefully you were able to follow the examples. You can always reach out for help you need. Summary's a little long today, so the examples were shorter, summary's a little longer. Which theorems have converses? So just go back and look at the vocabulary. Which ones have converses? How do you use the converse to solve problems? So I wrote that out as well, but the red question is asking about, like, when do you use a converse versus the theorem? So you should be talking about how you're using the converses to prove two lines are parallel. Last question, briefly summarize how the transitive property can be used with parallel lines. How have we been using the transitive property? And the homework is on big ideas as well. Have a great day.